this process, we're taking a 5/16 UNF, standard AN thread for 5/16, and tapping in from the top side. Barry's standing off in the distance and telling me if I look perpendicular to this plane. I examine from this direction, making sure that I'm perpendicular fore and aft as I do the tapping operation of that 2024 T3 at least quarter-inch thick insert, and we've gone all the way through it. I'm going to show you the ball that goes in here in a moment, so hold tight. I suppose the reason that we go right through is that how we can make sure that we're on parallel threads. Here is the ball thread. The way your barrel is set up, the barrel is far enough into the longeron, low, that there's space underneath this for stacking washers for a final adjustment on how tight this ball actually can seat into its receptacle. There's the whole prep. There's going to be some trimming necessary to make all this work. The point of radius, of course, is up here on the canopy bow. So if we draw a line straight from that hinge point to here, it describes a line at an angle. And movement, as the canopy closes, is going to be perpendicular to that line, which means this whole receptacle and the ball will describe a somewhat diagonal, or I should say circular path as it enters its receptacle. And you'll be examining that process with us as we discover exactly how it relates to the latching mechanism. We'll be back with you in a moment. Okay. Attempting to get all these lips the same height on a single plane. Take the old sanding bar here, and with an assistant, he pushing up against the bow, work it back and forth. You find that the high is a little high, the center is a little high, and rotate this just a little off of plane, and it'll take just the middle off. As you can see, we're working just the center. That's how that goes. We'll be back to you for the next step. We've played with the latches and worked on how they actually function. The design's been around for a little while in Glenn's head, and I've been mulling it around in mine for some time. A number of conditions here we wanted to meet. One of which, if the canopy were not intentionally latched, the canopy would not close. Canopy comes down, the ball drops against the barrel, which is a very simple affair. It is a machined barrel, 3/8 hole bored to the center with a ball end mill, and it's almost precisely to the middle of this barrel that it's drilled. And then a slot is put through it, 3/16 or so. Happens the ball drops in from above. If the canopy is in the unlatched position, it drops onto the slot. When the barrel is rotated, the ball can drop in, and then when it's rotated anywhere beyond, I'd say 90 degrees of rotation, up to 90 degrees rotation, it's locked. You would have to pull the entire barrel, its receptacle, and the associated phenolics that they're attached to through the longeron. A physical impossibility. So we have to bang. Bring it up to this position, and the ball drops into the latch. Well, it's sitting in this position, it cannot inadvertently latch, so that if you're taxing along and it's not latched, it will be obvious to you. We're probably going to have it so it's spring loaded in the latched condition. So you have to pull this handle back for the ball to drop in. And you have to do it on the left side and the right side. You push forward, and it begins to pull the shaft down into the receptacle. Now this is threaded up into your canopy. Now this, because your hinge line from the point of rotation above is diagonal to this describes an arc as it comes into the receptacle. So it means you have to taper the hole from top front to top bottom of this depth. It's about 5/8 of an inch thick here. Almost all solid phenolic. So you can grind it to shape. I start off by using a taper reamer from the top until I'm all the way down inside. And this operation should be done with the back side of this fluxed so that you have something to taper into. This will not be installed at the time. This will be out of the aircraft. So you take your taper reamer in here, bring it down the center, and you can watch the end of the taper reamer in the center of the bottom hole that you drilled. So again, this is backward flux up above. Bring it in all the way to the bottom, and after you get that tapered, then do any hand work necessary to get this thing to be able to describe the arc and drop in. When we first tried it, it didn't work at all. The tolerances of the hole were too close. There was also too much friction on the body of this, and soon we waxed this and kept this from turning on the inside, which closed off the opening. It worked perfectly. The canopy drops in place, and the latch moves forward, firmly pulling down the canopy as you move the handle, which is exactly what we wanted to accomplish. I'll show you the portions of this operation on this latch as I go along. This is the tool that I mentioned before. First thing we do is slide all the goodies out. They will get in the way. And if you're looking from this side, you'd see that the taper reamer drops into the bottom of the opening on the other side, keeping it centered. I'm working on this one. Make sure I have it visible here. The only problem with this taper reamer is it fills up with phenolic and such as I'm going into the hole. So you have to do some of the tapering, pull it out, clean out the reamer, and go back in again. This is a cautious approach to removing the material. You probably could drill it out with a unibit. Actually, that would probably be the better thing. The unibit that starts at 1/8 of an inch and then works up would work very nice. I'll be back to you as we try that. Okay, now we're going to try a different device here. One that has a 1/4 inch pilot. Well, what a sweet job that does. I wish I could show you what I'm seeing here. Superb. Now I'm just up to the edge of this. Now I can take that taper reamer on the inside and work the rest of it down lower. Ooh, what an ugly sound. The inside phenolic we've gone through the edge of, so that's what you're hearing. It's trying to, as it tries to stay in the hole. And as it does so, it's trying to push the reamer sideways. So now it's time to go with a hand grind to retain the round perimeter of the hole. So I'll get the hand reamer out, or hand grinder, and I'll be back with you in a moment. Here we have the rear canopy going together. The biggest difference is that we've got two bows to do at the same time, and we're going to approach this just a little differently. than we did the last one. We proceeded with West Systems 2-ply layup around the perimeter, the entire perimeter. The whole process was driven by the fact that we had to get all this stuff done in one shot so we could take advantage of chemical cure from one thing to the next. And we needed to get it done yesterday and not lapping into today. Since it went till late in the night because of the prep, we went with West through the entire process. But we don't have to do that with this one. Barry's going to be working on this completely by himself and has done this prep work in less time than it took us to do the original one since I left him alone. He's got his sheet wax down, he's got his white plastic tape in place, his safety tapes in place, he doesn't dribble all everything. Now what he's going to do is he's going to do this frame in West. That's the only part that he has to do in West if he doesn't have to wait for a long time before it becomes tacky enough to put flocks on top of the surface, pot it down in place, and then backfill with micro and do the tapes. So what he'll do is he'll do the 2 plies from this end to that end, both sides. Having done all the prep on the canopy, he'll brush safety epoxy on the interior of the bow, pot this down into West flocks, that's right. I'll get this right eventually. And then follow with 2410, 2183, 84, or 87 resin around the perimeter of the bow with the 4-ply glass tapes, both aft and front, and then 2410, 2183, 84, 87 micro on the interior, and he'll do all these tapes on aluminum foil. You've seen them done before. We're not going to show you that process again. The latch assemblies and drillings are the same as the front. We have one more piece of tape to show you at the end of this whole process, which would be the hinges at the upper aft end of each canopy. There'll be a few things with canopy latches and micro switches downstream and another tape. But the last tape we show you will be the hinge assemblies at the upper aft ends of both canopies. And that'll be the end of this portion of the rear canopy. You'll notice between the canopy frame and the edge, Barry, stick your finger in there, please. Give you some scale. There's a much larger gap than on the forward canopy. Take this opportunity to put as much aluminum in there as you can vertically, get as much bearing area on the threads as possible.